totally isolated from the rest of the molecule, and we do not have to worry about the splitting pattern. And as for the chemical shift values, you can get these in the data booklet. So since we are looking at the spectrum right now, we can just confirm that it's ethanol. So first we have a CH3 group over here. We have a peak over here for these three hydrogen atoms, and it is around 1.1 or 1.2. And when I look at the data booklet, this chemical shift is between, we get a peak between 0.9. We get a peak between 0.9 and 1.7 ppm. So as you can see, we are getting a peak between 0.9 and 1.7 ppm, and for the CH3 group. So yeah, this is correct. Now, if you look at this this peak, which corresponds to the CH2 group, we have to, in the data booklet, there is a column for carbons attached to oxygens, and for that the range is between 3.2 to 4.0 ppm. So 3.2 to 4.0, and as you can see, it is between 3.2 to 4.0. So this confirms it. And for the OH peak, we get a really wide range. So like we get over here, I can see in the data booklet, we have a 0.5 to 6.0 ppm. Okay, so we have the range for the OH peak is between 0.5 to 6.0 ppm, so it can be anywhere between 0.5 to 6.0, and as you can see, it is between 0.5 to 6.0. So the fact that there is such a large range for the OH peak poses some problems, because it can literally be anywhere. So for ethanol it is here, for some other molecule it might be here, for some molecule it might be here, so you never really know where it is. So for that reason, what we do, for that reason we do two things. So one is, one you'll get to know later, and the other thing we do is that we look for the singlets. So when we have a singlet over here, then we know that it might be OH or it might be NH. So this singlet is a very strong indicator that it might be an OH group, and the fact that it's such a small peak, the height is so small, also confirms it, because only one H atom attached to this. And I'll tell you another trick for NMR spectra. Whenever you see a triplet like this, we'll discuss what triplets are in the next slide. Whenever you see a triplet like this and a quartet like this in the same spectrum, where is my cursor? Yeah. So a triplet like this and a quartet like this in the same spectrum, we know that CH3 and CH2 must be there. So like in A-level chemistry, whenever I've solved a paper and I've seen these two peaks together, I just know that somewhere in the molecule I have a CH3 attached to a CH2, because these two contribute to each other's splitting patterns. And I can make a line over here because for the rest of the molecule, but I know that this will be there because I have a triplet like this and a quartet like this, because 3 plus 1 gives 4 and 2 plus 1 gives 3. So CH3 and CH2. If you see two peaks like these in the same spectrum, then your first guess should be this. And that's a really helpful hack because it will help you solve many spectra very easily in a very short amount of time. Okay, so now we move on to what we call these lines. So we actually don't call these lines, we call them singlet, doublet, triplet, and quartet. So for the oxygen, we saw a single line, so it is called a singlet peak. We did not see any doublet peak over here, but for example, if the neighboring carbon atom had only one hydrogen, then we would have seen a doublet because N would be equal to 1 and N plus 1 would be equal to 2. So N is equal to 1, N plus 1 is equal to 2. And we saw a triplet, which is 3 lines.